Hi guys, today we're going to be talking a little bit more about slope. Section 1.5 in your book is actually called More on Slope. So that's what we're going to talk about. So we're going to start today talking about parallel and perpendicular. And again, I think that these are topics that you have talked about before. You are probably very, very aware of it, and so we're not going to spend a lot of time on it, but let's define a few things. What do we know about parallel lines? Well, parallel lines have the same slope. And what do we know about perpendicular lines? Perpendicular lines have slopes that are opposite reciprocals. And we're going to use this information to help us write different equations of lines. So remember that when we write the equation of a line, we really need a point and a slope. We're going to write a point-slope equation, and then we're going to change that into slope-intercept form. So let's start with an example. We're going to write the equation of the line through the point, let's use -2, 5. And parallel to y equals 3x plus 1. Now, in being able to do this type of question, again, we need a point and a slope. We already have our point. It's here, -2, 5. We have some information about the slope, even though it's not given to us directly. So we know that our line needs to be parallel to this one. So if I know the slope of this line, I can then know the slope of the line of the that I want to write. So we're going to look at this one. This one's already in slope-intercept form. So we can easily identify this slope as 3. And so we know that the slope of our line is also going to be 3. And we can write our point-slope equation. You've had lots of practice with this, so I'm not going to spend a lot of time on it. Okay, y minus 5 equals 3 times x plus 2. And then we'll follow the steps to change that into slope-intercept form. So we're going to end up with y equals 3x plus 11. So we have the equation of a line that is parallel to this line, but that also goes through the point -2, 5. Okay. All right, let's do another example. Let me erase. This time, we're going to write the equation of the line. Passing through the point -2, -6, and perpendicular to x plus 3y minus 12 equals 0. Okay. So again, in order to write the equation of a line, we need a point, we need a slope. We have a point, -2, -6. We have information about the slope, but we don't actually have the slope. In fact, we know it needs to be perpendicular to this line. Well, in order to find the slope of our line, I'm going to need to know the slope of this line. And to get the slope of this line, I'm going to need to change this general form equation into slope-intercept form. And to change it into slope-intercept form, we're going to put the equation in slope-intercept. Or we're going to solve the equation for y, get y by itself. So that means I'm going to add 12 and subtract x from both sides. So I'm going to end up with positive 12 and minus x on the right. And then we're going to divide everything by 3. You have to be very careful here because we need to divide the 12 by 3, which is 4. And then we're going to end up with x over 3. And I'm going to write it that way for just a moment. And then remind you that instead of writing x over 3, we can also write 1/3 x. And this will make it easy maybe then to see the slope. So be careful because a lot of times people make the mistake in slope-intercept form where they think something's in slope-intercept form and they just assume that the very first number you run into is the slope and the second number is the y-intercept. But that's not the case. The slope is always going to be with the x. So in this case, our slope of this line is negative 1/3. And I need the slope of the line that is perpendicular to that one so I can write my equation. And we said that perpendicular lines have slopes that are opposite reciprocals. Opposite referring to positive or negativeness. So since this one is negative, this will be positive. And I need the reciprocal of 1/3, which is 3/1 or 3. So now I have a point, I'll remind you, -2, -6. I have a slope, positive 3, and I am ready to write the equation in point-slope form. We're going to get y plus 6 is equal to 3 times x plus 2. Then we'll follow our steps again to change this into slope-intercept form. Now this one's kind of interesting because when I subtract 6 on both sides, I end up with 3x plus 0, or I can just write this equation y equals 3x. All right, so that's an example of writing equations that are parallel and perpendicular. You're going to be doing some of that on your homework today. We have one more topic we need to talk about with regards to slope, and this is actually really kind of exciting because this is sort of the beginnings of calculus and really kind of the foundation of calculus. So another application of slope is rate of change. And sometimes you'll actually hear slope referred to as the rate of change. Okay? And in the case of calculus, what this is helpful in is sometimes if we are looking at a graph of a function that is not a line, so we're talking about the graph that is some sort of curve, it is nice if we can figure out the average rate of change between 2 points on the graph. So for example, I'm going to draw a little graph here. I might have this function that's been graphed. Okay. And I have a point on the x-axis that I'll call x1. I have another point called x2. So I have this ordered pair, which is here, and I have one here. And I want to know the average rate of change between these 2 points, which is going to be the slope of the line that connects those 2 points. That's going to be the average rate of change of this function between x1 and x2. And this line actually has a special name. It's called a secant line. S-E-C-A-N-T, pronounced secant. Okay. So that is kind of important and actually a very, very important concept that we will talk about next year in calculus. So very exciting. So let's look at an example of a type of problem. Find the average rate of change of f of x equals x cubed from x1 equals -2 to x2 equals 0. Okay. Now, let's consider this graph for a moment. This is not going to be a perfect exact graph, but we'll get kind of the idea of it. If we're talking about a cubic function, y equals x cubed, that function looks something like this. Okay. And this says that we would like to find the average rate of change from x1 equals -2, so wherever I might have -2 here, so I have some ordered pair here, which is at -2, and x equals 0, or x2 equals 0, which is actually going to be right here. Okay, so this is x1, and this is x2. Okay, and we really want to find the average rate of change. We're really looking for the slope of this line, which is called a secant line. Okay, so let's label that secant line. Okay. In order to find the slope, we know how to calculate slope using the slope formula, but we need to have two ordered pairs. Well, how can I find the ordered pairs? Well, I'm going to evaluate f of -2, which is going to be -2 cubed, or -8. And I'm also going to need to find f of 0, which would be 0 cubed, which is 0. So my two ordered pairs are -2, -8, and 0, 0. Okay. At this point, and I'm going to bring this up here, I'm going to find the slope between those 2 points, which are on the graph, which is connecting the secant line. So m is going to be -8 minus 0 divided by -2 minus 0, which is -8 over -2, or +4. So the average rate of change of the function f of x equals x cubed between -2 and 0 is 4. This is not a fantastic picture, but you can tell. We know that a slope of 4 is fairly steep. It is going to be pretty steep in between there. If you would like to get on a graphing calculator or a graphing website, you can always check that out and see how steep that line is. Okay, so that's another thing that we use slope for to help us deal with when we're talking about things that are not lines, but we still want to get maybe just an average. What's happening on average between 2 points on a graph. Okay. All right, so you're going to be on your assignment today writing equations of lines that are parallel and perpendicular to other lines, and then also you're going to be looking at some problems where you're finding the average rate of change, just like the problem I showed you here, and that's it. So today is Wednesday, so on Friday you're going to be doing some review over sections P6 through P9, and then when I return and am back with you again next Thursday, we're going to go over all of these things and finish reviewing up P6 through P9 so that we can have our test the following Monday, right before Thanksgiving. Okay? All right, so your assignment for today is on page 200 and 201. You're going to do 1 through 26 all. Okay, so this assignment's a little shorter than the last one. And there it is. Okay. You will not have a video to look at on Friday, so this is the last video for me. So I will see you all next week. Have a great day.